PO15 where we put everything together. That's enough.
What?
Everything together. We are using multiple rules for all of our expressions. If you look down at your homework, you can see that everything's got a little bit of flavor, right? We've got, in this first one, multiplying by the same base and dividing by the same base. Second one, you've got negative powers and you're just distributing. Down here, ooh, looky, you've got a zero power. You've got multiplying by the same base. You've got fractions. You've got a negative power and you have parentheses. All five of them lumped into one magnificent expression, right? But that's what PO15 is. So we're going to start by going over each of the rules. This is a key point. This can go on a help sheet. Who is making a help sheet as we go along? Okay, you should be. If not, this is a summary of the entire unit. The entire unit.
Wait, help sheet right now?
Well, this can go on a help sheet. Like, if you want to make one, some people make one as the unit carries on. Some people wait till the very end. But multiplying by the same base. Okay, you know this is going to be something with multiplying by the same base because of the multiplication symbol, right? It'll say 6n cubed times 9n squared. If you see the multiplication symbol in it, you know that you are multiplying by the same base. This is CO10, and who remembers what happens to the coefficients? The coefficients in this rule, yes. They are multiplied. Yeah, I should give you a little key to my notes here. C stands for coefficients. E stands for exponents. And B stands for base. The same charts that we filled out rule by rule through the unit. Now they're just all in one happy little place for you. What happens to the exponents when you multiply by the same base? Yes? They get added. That is correct. And the base, as we've seen in many of them, stays the same. Right? Stays the same. So this answer, 6 times 9, those coefficients get multiplied. N cubed times n squared is n to the 5th. Okay? Coefficients multiplied, powers added. Dividing by the same base. How do you know that you'll be dealing with dividing by the same base? What is going to be your hint in the expression? That it's dividing by the same base. Yeah. A fraction. If you've got a fraction, such as 8n to the 10th over 6n to the 7th, right? You see a fraction. That's your hint that you are dividing by the same base. And what happens to the coefficients in this rule? Gabby? They get simplified. Now, in parentheses, we put divided, and they really are divided, but if you have something like 8 divided by 6, that doesn't work out evenly, don't put a decimal, okay? In this case, you simplify that fraction to get 4 over 3, right? Everything's kept in fraction form. What happens to the exponents? Landon?
They get
subtracted. And then the base stays the same. So this answer, 8n to the 10th over 6n to the 7th, we have the coefficients taken care of. What happens to the powers? What are we left with and where are they? 10 minus 7 is 3. And since you had more in the numerator to start with, that's where your 3n's are going to be. 4n cubed over 3. Okay. The zero exponents. In this case, we don't really care about the exponent because it's 0. That's why it's called the zero exponent rule. But whether your base is a number like 9 to the 0 or a variable with a coefficient, right? This is the one where the base changes. What does the base become? What does the base become?
1.
A 1. Okay? The base becomes a 1. So 9 to the 0 equals 1. 4n to the 0 equals 4 because what do we do with the coefficient?
Multiplied. Divided. Subtracted. Added.
None of those things.
Simplified.
Gabby. Stays the same. This is the one where actually the coefficient stays the same. And the reason why it stays the same is because it's not part of the exponent. It's not affected by the power. This becomes a 1, and 4 times 1 gives us 4. Okay, 4 times 1 gives us 4. So this is the rule where the role of the coefficient stays the same. Nothing happens to it. Negative exponent, obviously you'll know you're dealing with a negative exponent when you have a negative exponent. This is the rule. What happens to the coefficient in a negative exponent? Look back if you need to. Landon?
They're unaffected by power.
They're unaffected by the power. The coefficient stays put. It doesn't move anywhere. Okay, what moves is the exponent. That negative power moves and becomes positive. Right? It moves and becomes positive. When we say it moves, we mean it moves to the other part of the fraction. It's negative because it's not in the correct part. So you just move it to the correct part. It's negative at the top, positive on the bottom. It's negative on the bottom, positive on the top. It just switches. And then the base does what? Gabby?
Stays the same and moves it.
Yes. It moves with the power, and it does stay the same. It does not change. Then finally, the last rule number 5, we just corrected homework on it for today, distributing exponent into parentheses. This is your hint that you're dealing with this rule. It's got parentheses, okay? And I don't know why I put this V here. I think I meant like variable coefficient or variable base. I'm not quite sure. It doesn't really, just cross out the V's. I don't know what I was thinking with those there, but I probably told myself last year at this time to change it for this year, then forgot. I'll probably do the same thing next year. But anyway, when you distribute an exponent into parentheses, what happens with the coefficient? Yeah.
Takes on.
It gets the power. It gets the power. So if we have something like 4n to the 6th, and that's being taken to the 7th power, right? You distribute the 7, that coefficient of 4 gets the power. Just becomes 4 to the 7th. And then the exponents, what do we do with the 7 and the 6 there? Exponents are multiplied. Okay? And once again, the base stays the same. That n doesn't change. Still n to the 42nd power here. Okay, the n doesn't change. Questions on any of those rules? I mean, if you understand this, you're going to do very well on this test, because this is basically it. This is objectives 10, 11, 12, 13, 14, 15, puts them all together. If you think back, PO9, that was just expanded form and things like that. So if you get, this is the gist of it here. Okay. For tomorrow, your homework, and we'll do as many as we can before you exit today. This page, but don't do these as a challenge. I will not consider them part of the assignment. We will still go over them tomorrow so that you can see the answer if you did them. But I only want you to focus on those 6 for homework. They contain 1 or 2 rules each, whereas the last 2 contain 3, 4, maybe even 5. So if you want to tackle them, be my guest, but you don't have to do them. That being said, which one of those 6 would you like to go over before we go? Landon.
5, 8, and 4.
The second one? Here? Okay. So you take a look at that second expression and you see a negative power, several of them, and you also see parentheses. So the 2 rules that you know you're going to need to use are negative exponents and parentheses. Okay? On the previous page, we simplified within the parentheses first. I wouldn't recommend doing that here because that negative exponent on the outside is going to change the sign of everything on the inside. So everything that you don't have to move right now because the power is positive, you will. Everything you do have to move right now because the power is negative, you actually won't. Because what happens when you multiply by a negative is the sign changes. So that becomes 5 to the negative second power. A to the fourth becomes a to the negative eighth power. We didn't have to move it originally because that 4 is positive. However, now we will. Right? Negative 3 times negative 2 is b to the positive 6. Don't have to move that anymore. C to the negative 8 to the negative second is c to the positive 16th. Don't have to move that anymore either. So our final answer, b to the positive 6th, c to the 16th, over what we have to move now, 5 to the positive second, and a to the 8th. So the two rules this one included were negative powers and parentheses. Right? So those other 5 I'd like you to do on your own. Just take a look at what it has, and remember, do something, and eventually you will do everything. If you ever have an answer that has more than one of the same base in it, you can go further. Okay, you can go further. Questions, comments, concerns, complaints, comments, congratulations, criticisms? That is how you math.
Don't forget to like and subscribe.